Welcome to my class. I'm Drew Collip. In today's class, we're going to build on what we learned earlier regarding linear equations, and now we're going to look at systems of linear equations. This is when we have to solve two different linear equations and get the same value for x and y for both those equations. There are three possible outcomes. There is a single point, meaning we have one linear equation and we have another linear equation, and that point right there is the solution. Another possible outcome is we have one linear equation and we have another linear equation, and they are parallel and they never intersect. There'll be no solution to this system of linear equations. The third possible outcome is when we have one linear equation and we have another linear equation and it is the same equation, in which case there are an infinite number of solutions. So just to summarize here, the first case, we get one answer. These two lines come together, they meet once and they never meet again. We have no solutions, these two lines are parallel, and they never come in contact with each other. The third outcome is there's an infinite number of solutions because the lines are exactly the same. So those are the three possible outcomes when solving systems of linear equations. Let's examine how to solve systems of linear equations graphically. I've kind of already showed you that when I was explaining the three possible outcomes. Your first step here, you plot one line on your graph and then you plot the second line on the graph. Determine where those lines intersect and get that coordinate, the x and y coordinate. This will be your solution to this system of linear equations. Let's look at an example. Let's solve this system of linear equations. You can see they're already written in slope-intercept form, so I can get the slope for this one and the y-intercept, giving me a coordinate of 0, -2. Down here, I can get my slope, 1/2, and my y-intercept is 3, giving me a coordinate of 0, 3. Let's plot these and see what the solution to this system of linear equations is. Make sure we put our scale on here. Let's plot the first one in red. We have our y-intercept at 0, -2, right here. And then our slope is 3, meaning we rise up 3, we move over 1. Rise up 3, move over 1. When you do this, it's very important you make the straightest line possible because we're looking for where they intersect. If you're off at all, you won't get a correct answer. Ideally, use a ruler to make this line. Now let's graph our second linear equation. Here our y-intercept is 0, 3, right here. And our slope is 1/2. So rise is 1, run is 2. So I go up 1 and over 2. Up 1, over 2. It also works the other way. I go down 1 and back 2. Connect this with a straight line, straight as possible. This one is easy to solve because we see exactly the same point here. So this right here, this is your solution to this system of linear equations. X is equal to 2 and y is equal to 4. You can actually get a coordinate 2, 4. This is the only x and y values that will solve both the first and the second equation. So there is one solution to this system of linear equations. Let's look at another example here. Here we also have two linear equations. You can tell it's a linear equation because they have an exponent of 1 on both the x and the y variable. But notice here, this has not been presented in slope-intercept form. So our first job is to rearrange it so we get it in slope-intercept form. Move everything that's not y to the other side. So the 4x goes the other side, makes -4x. To eliminate the -6, we divide everything by -6. These will cancel out, giving me y is equal to a negative and a negative makes a positive. Simplify 4 over 6 to 2 over 3x minus, because we're saying 12, divided by negative 6, we get minus 2. Our slope is 2 over 3, and my y-intercept is going to be 0, minus 2. Let's look at our second equation. It is also in standard form. So let's rearrange it to get it into slope-intercept form. Move everything without a y to the other side. To isolate your y now, divide everything by 2. These will then cancel out, leaving y on its own. Negative 2 divided by 2 is going to be negative 1x. 6 divided by 2 is going to be 3. So here I get a slope of minus 1 and a y-intercept of 0, 3. Let's now graph it and find this solution to the system of linear equations. Let's plot our first line in red. It crosses the y-intercept at 0, minus 2, right here. And our slope is 2, 3. So it rises up 2, moves over 3. Rises up 2, moves over 3. Drops down 2, moves back 3. Use a ruler to connect this with the straightest line you possibly can. Let's now plot the other equation in green. Our y-intercept is 0, 3, so it's all the way up here. Our slope is minus 1. So I drop down, move forward 1. Drop down, move forward 1. Drop down, move forward 1. You can see they connect up there. Again, connect this with the straightest line you can. You can see there is one solution to this system of linear equations. It is right there. Our solution is x is equal to 3 and y is equal to 0, giving me a coordinate of 3, 0. There's exactly one answer to this system of linear equations. Let's now look at a word problem. As a homeowner, oftentimes there are repairs that need to be done to your house. Maybe you don't have all the skills necessary, so you'll have to hire a contractor to come in and do some of the work. Let's assess some of these companies. We have a company called Easy Contracting. They have an initial fee of $350, and then they charge you an additional $100 per hour. That's their rate. We have another company, Helpful Contracting. It has a lower initial fee of only $150, but their hourly rate is higher, $150 per hour. We can work with a system of linear equations here to find out which company we should hire. We can use a system of linear equations to find out which company would be the most economical one to hire for our job. Let's build an equation that relates the cost to the amount of time worked for each of these companies. So we have the Easy Company and we have the Helpful Company. These are all just made up. We want to relate the time worked, T, to the cost, C. So our cost for Easy is going to be, what is it? We initially have a fee of $350, and then we add to that our time multiplied by $100. For a Helpful Company, their cost is an initial fee of $150 plus their time multiplied by their hourly rate of $150. Notice I can turn this in to an equation in slope-intercept form. Same over here. Here's our slope, here's our y-intercept, here's our slope, here's our y-intercept. Even though we're not using x and y, we can still use those same principles. For the Easy Company, our slope is 100, and our y-intercept, our initial cost is $350. For the Helpful Company, our slope is 150, and their y-intercept is also 150. That's the initial cost. They come in, they do no work for you, it costs $150 for Helpful Company. For Easy Company, they come in, they do no work for you, $350. So we're going to solve the system of linear equations, graphing it up to 6 hours worth of work. We'll then assess what this represents, and we'll look at which company we should hire for various number of jobs, depending on how many hours they work. Let's graph that now. We'll label on the bottom time, and this is in hours. We'll label along the side here cost. This is in Canadian dollars, we'll say. That's important. Different currencies around the world, this will be in Canadian dollars. We're going to graph it up to 6 hours. To maximize our scale, we have 6 hours. We have how many blocks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 blocks. I divide that by 12 intervals. What I get here now is 1/2, hours on the top, intervals on the bottom. So 1 hour is 2 intervals. 0, 1, 2, 3, 4, 5, and 6. Maximizing our use of the scale. In terms of our cost here, we're not exactly sure how high it's going to go. We'll go up by 200s. 200, 4, 6, 8, and 1,000. Hopefully it won't cost more than $1,000. Let's plot easy on there. So for easy, we're dealing with a y-intercept of 350, and our slope is 100. So we initially cross the y-axis at 350, right about here, and our slope is 100, meaning we go up 100 and over 1. Up 100, over 1. Up 100, over 1. Connect that with a straight line. Now let's graph the helpful company. Here we have a y-intercept of 150, and our slope is 150. So we're crossing the y-axis at 150. We go up 150 and over 1. Up 150, over 1. Up 150, over 1. Up 150, over 1. Up 150, over 1. Connect this with a straight line. Now, what's the solution to this system of linear equations? It's right here. My coordinate is going to be 4, 750. There's only one solution to this system of linear equations. It's where they cross. 4, 750. What does this represent then? Go up here. It says, what does the solution of this system of linear equations represent? This represents that at 4 hours, the cost is identical for both. $750 is what it costs you for 4 hours work, regardless of what company you go with. The next one's, who should you hire for the job if it will take 2, 4, or 6 hours? Well, you can see any job less than 4 hours, you should go with the helpful company. Any job more than 4 hours, you should go with the easy company. If the job is exactly 4 hours, it doesn't matter who you go with. It's exactly the same cost. Here's just an example of how you might use systems of linear equations. And trust me, as a homeowner, the rates can vary greatly between different companies. So it's good you do your homework to make sure you're getting the best value. Also remember, you don't always get the best workmanship for the cheapest rates. That's not mathematics, but it's very important for something to take into consideration for the real world. So we've solved systems of linear equations using graphs. You can see it works out. We graph the lines, and where they cross, that is the solution. However, this is quite time-consuming. There's other ways to solve systems of linear equations using algebra. Let's look at that now. We can use 2 different methods to solve systems of linear equations. The first one is called substitution. We're going to substitute one equation into the other. Here's the process. We solve for one of the variables. We then substitute in what that variable is into the other equation. We will only have one unknown then. Solve for that unknown, and then once you get that unknown, substitute it back into the original equation and check your answers by subbing into both. Let me show you what I mean. So example 4, here's a system of linear equations. We have x plus 4y equals 6 and 2x minus 3y equals 1. Here, they're both in standard form. I like to keep track of these things. I'll call this equation 1, and I'll call this equation 2. So I'm going to solve for x in equation 1. X is equal to minus 4y plus 6. Now that I know what x is equal to, I'm going to substitute that in right here. This is why this method is called substitution. So I'm going to sub into equation 2. When you're working with big problems, it's sometimes helpful to add these little reminders along the way to show you what you did. So equation 2, we have 2x minus 3y equals 1. I'm going to substitute in this whole thing in for x. So I'm going to remove the x and place in its place what x is equal to in the other equation. You can see by doing that, we've eliminated our x variable. We only have a y variable left. So let's solve for y. Distribute your 2. Collect like terms. Swing the 12 over to the other side. Divide both sides by minus 11 to isolate y on its own. And here I get y is equal to 1. So I solved for one of my unknowns. But don't stop here. This is a common mistake students make. They solve for one of the two variables. Don't stop there. What we have to do now is we're going to sub y is equal to 1 into equation 1. So we had equation 1. Sub it back into the original problem. The reason why we sub it back into the original problem is because if we sub it into this one, we might not get the correct answer if we made an error when switching from one to the other. So let's substitute in. We had x plus 4y equals 6. We're going to sub that in here, 4y. X plus 4 equals 6. Swing the 4 to the other side. We get x being equal to 2. Therefore, we have a final answer of 2, 1. You can sub it in and double check. If I sub 2 in here and 1 in here, 4 plus 2 is 6, so that works out. Sub it in over here, we have 2 for x and 1 for y. 2 times 2 is 4, minus 1 times 3. That's going to be equal to 1. You can see this solves both systems of linear equations. This is the solution to this system of linear equations. Let's try example 5 now. We'll call this equation 1. We'll call this equation 2. Let's solve for y in this case. Y is equal to minus 2x plus 6. We will then substitute this in here for y. So I'm going to sub into equation 2. For equation 2, I had 3x plus 2y equals 10. I'm going to remove the y and put in its place 2x plus 6. Distribute this, distribute the 2, and solve for x. X is equal to 2. Now we'll sub x equal to 2 into equation 1. Remember to sub it back into the original equation. We're going to substitute 2 in for x, and now we'll solve for y. So the solution to this system of linear equations is going to be 2 and 2. You can double check that. 2 times 2 is 4, plus 2 is 6. Over here, 2 times 3 is 6. 2 times 4 is 4. 6 plus 4 is 10. So we just showed both ways that 2 is the solution to this system of linear equations. We have a number of practice problems here. I'd like you to try these on your own. Solve for the system of linear equations. We have 1, 2, 3, 4, and 5. Don't do 6 yet. We'll do 6 together later on. For a few of these problems, you're going to get some strange answers. Go back to the beginning of the lecture and remember, there are 3 possible solutions to a system of linear equations. Possibility 1, there is one answer. Possibility 2, there is no answers. Possibility 3, there are an infinite number of answers. Keep that in mind as you work on these. Let's take them up now. I'm not going to take up 1 and 2. I've given you the correct answers here. If you have problems with this, you can ask me during tutorial or email me outside of class. Let's take up some of the other ones. Let's take up 3. You probably got a strange answer for question 3. So we have equation 1 and we have equation 2. Let's solve for x using equation 1, and then we will sub in x into 2. So equation 2, 2x minus 8y equals 8. We're going to substitute in what we solved for the other one. By doing so, we've eliminated the x variable. Please note, when working with systems of linear equations, you can solve as many variables as you want, as long as you have that many different equations. For an example here, I have 2 unknowns, x and y, so I need 2 different equations. If I had 3 unknowns, I could solve for all 3 as long as I had 3 different equations. You guessed it, for 4 variables, we need 4 different equations. Let's solve this now. These cancel each other out, and I end up getting a weird answer. I get 16 is equal to 8. That's kind of weird, isn't it? Is 16 equal to 8? 16 is not equal to 8. What do you think this means? This means there is no solution to this problem. What does that mean then? It means these are parallel lines. So we have one line here, and we have another line here. They never cross, therefore there's no solution. One way you can tell that very easily is by converting these to slope-intercept form. This would be minus 4y equals minus x plus 8. Divide everything by minus 4. Y is equal to 1/4 x minus 2. For the other problem here, we have minus 8y equals minus 2x plus 8. Divide everything by minus 8. Y is equal to 1/4 x minus 1. Notice they have exactly the same slope. Therefore, they will be parallel. Question number 4. Not going to take that up. Here's your answer. We'll take up 5. 5, you also get a strange answer. So we have equation 1, we have equation 2. Let's take equation 1 and we'll solve for x. So 2x is equal to 6y minus 2. Divide everything by 2. 2's cancel out. X is equal to 3y minus 1. We will now sub that into equation 2. Equation 2, we had 3x minus 9y equals minus 3. I'm going to remove what x is. I'm going to sub in x from the other equation, and I will solve this. 9y minus 3 minus 9y equals minus 3. You can see these cancel out, and I'm left with minus 3 equals minus 3. Another strange answer. However, minus 3 is equal to minus 3. What does this mean? This means they are the same line. There's an infinite number of answers. What do I mean by it's the same line? Well, let's simplify both of them. 2x minus 6y equals minus 2. And we have 3x minus 9y equals minus 3. Let's convert both of these to slope-intercept form and see what we get. Over here, we do the same thing. See what you get? This equation and this equation are exactly the same. They just look different because we've multiplied the left and right side by different values. Your options are you get one answer, or you get infinite answers, in which case you will get both sides equal to each other, like we got here, or there will be no answers and you'll get a nonsense mathematical answer, like we had here. So just to summarize, if you get a number and they are not equal to each other, there is no solution because they are parallel lines. If you get a number and they are equal to each other, there is an infinite number of solutions. And they are the same line. So keep that in mind. If you don't get an actual answer in the end, if somewhere along the line you have to stop doing the math because your variables disappear, remember what these things mean. Let's go back and do 6 together. So here I have a system of linear equations. I have equation 1 and I have equation 2. Let's go back many lectures in the past. What did I say when we're doing algebra and we have fractions in our equation? Step number 1 is get rid of those fractions by multiplying both sides by the lowest common denominator. In equation 1, lowest common denominator is 8. Going to multiply both sides by 8. In equation number 2, lowest common denominator is going to be 6. Going to multiply both sides by 6. Remember, with algebra, as long as I do the same thing to both sides, I don't change the value at all. So equation number 1 becomes 8 times x over 2 plus 8 times y over 8 is equal to 4 times 8, which is 32. We can turn these into fractions. 1 2 comes out of here. 4 2's come out of here. Over here, 1 and 1. This will then give me 4x plus y equals 32. Much easier to work with. Let's look at equation 2 now. Multiplying everything by 6. 6 times x over 3 minus 6 times y over 2 equals minus 2 times 6 is minus 12. And we'll simplify. 3's come out, 2's come out. Giving me, you can see here, we've now made these much easier to work with. Let's solve for y over here. And we'll substitute in y right here. This gives me 2x minus 3 times y, which here was 4x plus 32 equals minus 12. We'll then distribute, giving me 2x plus 12x minus 96 minus 12. Collect like terms. 14x, swing the 96 over to the other side, becomes positive 96. Positive 96 minus 12 is going to be 84. Divide both sides by 14. These cancel out. And I'm left with x is equal to 6. I will then substitute in x is equal to 6 into equation 1, the original equation 1, the one that has the fractions. Remember, always go back to the original equation in case you messed up along the way. So x is equal to 6. 6 removes the x over 2 plus y over 8 equals 4. Let's solve for y now. Get rid of the 8. by multiplying both sides by 8. By doing that, you say these cancel out, and I'm left with y is equal to 8. So my solution to this system of linear equations is 6 and 8. Final answer. This one was a bit more challenging. Why? Because we're dealing with fractions. Remember, when you're dealing with fractions in equations, your first step should be get rid of those fractions by finding the lowest common denominator for both sides of that equation and multiplying every term, both sides, by that lowest common denominator. That is why we spent time doing this in fractions, because you need to understand the fractions in order to do this math. So this method was called substitution. We solved for one of the variables, and then we substituted into the other equation. By doing so, we eliminated that variable, and then we were able to solve for that one variable that's left. Let's do the other method. This one is called elimination. You'll see why in a second. So substitution is the one method, elimination is the other method. How do we do this? Step number 1, we pick which variable will be eliminated. Step number 2, we multiply each equation by an integer, right? Multiply left side and right side by the same number so that you have the same coefficient on each of those variables you want to eliminate. You add or subtract one equation from the other. By doing so, you'll eliminate one of the two variables, solve for the one variable that's remaining, substitute that known variable into the other equation, and then check your answer. Let me show you what I mean. Example number 6. We have equation 1, we have equation 2. If we look at these variables, I want to eliminate one. I have x or I have y. This one has already been set out for us. We have positive 3y, we have negative 3y. So what I'm going to do here is I'm going to say equation 1 plus equation 2. I'm going to add those up. See what happens when I add them up. When adding them up, I look at like terms. So I have my x's, 2 plus 5 equals 7x. I have 3y plus negative 3y. This gives me 0y. Finally, I have 23 plus 5, which is 28. You see what happened there? We're able to eliminate one of those variables right off the bat. 7x equals 28. Divide both sides by 7 to get rid of the 7 on the x. X is equal to 4. Now that we've solved that, we're going to substitute in x is equal to 4. We can go into either equations. I'm going to go into equation number 1. Equation number 1 was 2x plus 3y equals 23. Remember, go back to the original problem. Don't substitute it into this problem here. Well, you can't because the y is gone. Let's substitute that in now. We remove the x and put in its place x is equal to 4. We'll solve that now. Divide both sides by 3 to isolate the y on its own. So the solution to this system of linear equations is 4, 5. I would advise you to use elimination or substitution depending on the system of linear equations you have. In this case here, you can see we had one variable already set out as the same coefficient. So in this case, it would be easier to work with elimination than perhaps for substitution. Let's now examine example number 7. We don't have it so easy with example number 7. We now have to create coefficients that are the same. What do we want to eliminate? Let's eliminate y again. I don't know why, for some reason, when I do this, I always like to get rid of y first. What's the lowest common denominator between 2 and 5? It's 10. So let's make them both 10. So we'll say this is equation 1 and this is equation 2. To make both of these equal to a coefficient of 10, I take equation 1 and I multiply it by 5. This will then give me 5 times 3 is 15x plus 5 times 2 is 10y is equal to 5 times 2 is 10. Notice I multiplied everything by 5. For equation 2, to make that equal to 10, I multiply everything by 2. So here I get 2 times 4, which is 8x, plus 2 times 5, which is 10y, is equal to 2 times 12, 24. What I'm going to do now, I'll call this a new equation, equation 3, and I'll call this one equation 4. I'm going to take equation 3 and subtract equation 4. So I'm subtracting them. So this is a negative, this is a negative, and this is a negative. When I subtract those, 15 minus 8, 7x. 10 minus 10 is 0y. And 10 minus 24 is minus 14. 7x is equal to negative 14. Eliminate the 7 by dividing both sides by 7. These cancel out. And I'm left with x being equal to minus 2. We will now substitute in x equals minus 2 into our original equation 1. 3 times minus 2 plus 2y equals 2. Now solve for y. Don't forget to do that. One of the biggest mistakes students make when solving systems of linear equation problems is they only solve for one variable and forget to solve for the other one. Remember, we're looking for a coordinate, both an x and a y. Divide both sides by 2 to eliminate the coefficient on your y. So the solution to this system of linear equations is negative 2, positive 4. To double check, you can sub those in. Minus 2, and we have positive 4. Negative 2 times 3 is negative 6. 2 times 4 is 8. 8 minus 6 is 2. On the other hand here, we have 4 times negative 2, which is negative 8, plus 5 times 4, which is 20. 20 minus 8 is 12. You can see it checks out and is the solution for both of those linear equations. So a number of practice problems here. 1, 2, 3, 4, and 5. Give those a try on your own. I'll write down the answers for you. I'm not going to take any of these up, but here's your answers. I'll give you a hint for practice question 5. Your lowest common denominator here would be 6, and your lowest common denominator here would be 30. If you have any issues with those questions, solving them, please ask me during tutorial, or you can reach me outside of class. In today's lecture, we took our knowledge of linear equations and we used it to solve a system of linear equations. This is when we have two equations and we're looking for where they cross. I'm looking for a single point, x and y, that solves both of them. When solving systems of linear equation questions, you have three possible answers. There will be one answer, they cross at one point. There will be no answers, they never cross, they are parallel lines. Or they cross at every point. You actually have the same line. In this math course, I like to relate it to what you're going to actually use in the lab. You might be thinking to yourself, how is this applicable to working in the lab? Well, in a couple lectures, we're going to be doing mixture word problems, and we're going to use this to solve our mixture problems. And trust me, that's a very important solution for working in a laboratory by determining how much of a chemical you'll have to add, making up a mixture. That's all for today. Until next time.